So 9.4 talks about geometry's most elegant theorem, which is the Pythagorean theorem. The Pythagorean theorem itself states that in any right triangle, one leg squared plus the other leg squared equals the hypotenuse squared. The converse for that is if you have a triangle where one leg squared plus the other leg squared equals the hypotenuse squared, then you know you have a right triangle. And the converse will come more into play with the later problems where we'll have to classify triangles based on whether or not they meet this criteria. So I'd like to show you this interesting Pythagorean theorem proof using water. So imagine that the volume, the length times the width times the depth. Imagine the depth is just 1. That way it works with the areas. But here you have a right triangle with one square and the other leg squared. And when the demonstrator turns the wheel, the water from the two legs squared added together will fill the hypotenuse's square. So I think that's a really interesting demonstration of the Pythagorean theorem. What I'd like you to do, because I think it'll make today's homework a little more helpful, is I'm going to jump ahead a little bit with the information, and I'm going to ask you to write down these helpful Pythagorean triples, which are a 3, 4, 5, a 5, 12, 13, and I should back up a little bit and mention that the Pythagorean triples are the triangles, right triangles whose side lengths are integers. So the smallest right triangle that you can have whose side lengths are whole numbers is the 3, 4, 5, and you'll see that in every standardized test, that or some scaled, magnified version of it. Some of the other triples, the next one up is a 5, 12, 13. The third smallest is a 7, 24, 25, and then we have an 8, 15, 17. Two other specials that you're going to see in this homework that you, according to the book, they would like you to work it out using the Pythagorean theorem, but I wanted to introduce these special families now, are the 45, 45, 90 triangle. Specifically, if you had a square and then you drew the diagonal, that would break it into a 45, 45, 90. So I'm asking that you just write down the information in the yellow boxes for now. Let's take a look at an example. And within this example, I'm going to show you the reduced triangle principle. So here we have one leg is 6, another leg is 8, and we need to find the hypotenuse, which is x. So I'm going to write this up as a 6, 8x. Then I can factor a 2 out of the 6 and 8, and 6 divided by 2 is 3, 8 divided by 2 is 4. And then I recognize that as a 3, 4, 5. So I can write the 5 in there, and then to solve this problem, 2 times 5 is 10. Or we can use the Pythagorean theorem, where you'd write it out one leg, 6 squared, plus the other leg, 8 squared, equals the hypotenuse squared. So 36 plus 64 is 100, and then you'd get plus or minus 10. We'd get plus or minus 10, but since we're only dealing with lengths, we would reject the negative value and just see the positive 10 as the length of the hypotenuse. So using either method, you're going to get the same answer. So if we take a look at a couple more examples, 1a. I do recommend drawing out the triangle for each of these. They tell us that x is 4, that's a leg, y is 5, that's another leg, and we're asked to find the hypotenuse. So the leg squared plus the leg squared equals the hypotenuse squared. 4 squared plus 5 squared equals r squared. then 4 squared is 16, 5 squared is 25, and that's equal to r squared. 16 plus 25 is 41. When we take the square root of that, there is no perfect square or nothing to simplify or reduce within there. So r, the length of the hypotenuse, is just the square root of 41. In Moodle, however, you're going to need to use Excel or spreadsheet notation. So you're going to have to type SQRT, open parentheses, 41, and then close parentheses. If we take a look now at 1G, we have the leg squared plus the leg squared equals the hypotenuse squared. And the values that they gave us were one leg was 2 root 5. The hypotenuse, r, is root 38. So be careful and don't just assume that they're both legs. And we have to find the other missing leg. So here we can set this up and substitute 2 square root 5 squared plus y squared equals root 38 squared. And when we did this in class, I just used x because that's what someone told me. But we can change that quickly. There we go. So now when I square 2 root 5, I have to square the 2, which is 4, and square the radical 5. Any square root times itself is just the number. So then 4 times 5 is 20, plus y squared plus root 38 squared. When I square the square root, I get just the number inside. And then when I subtract 20 from both sides, I get y squared equals 18. Then when I take the square root, y is the square root of 18, or the square root of 9 times the square root of 2. Square root of 9 is 3. Square root of 2 stays as square root of 2. So I would enter into Moodle 3 asterisk, and you get that by shift 8, SQRT 2. Don't forget the parentheses. We'll do a couple more examples here. To find the length of the diagonal of a square with the perimeter of 12. So I'm going to start by drawing this out. If the perimeter is 12, we need to remember that a square has 4 congruent sides. So that would mean a side is 12 divided by 4, or 3 centimeters. And this goes back to that 45, 45, 90. So if I have that memorized, I automatically know that the diagonal is going to be 3 times the square root of 2 space centimeters. Or if I didn't know that, I could work it out as 3 squared plus 3 squared equals the diagonal squared. And then the diagonal would be the square root of 18, which is square root of 9 times the square root of 2, or 3 square root 2. So those specials, I think, will really help you do this homework a lot faster. And you will need to know them by the end of next week, so I strongly recommend using them if you can. The perimeter of a rhombus, whose diagonals are 12 and 16. You need to remember the properties of a rhombus, that they meet at a right angle and that they bisect each other. So then, if one diagonal was 12, then half of that would be 6. If the other diagonal is 16, then that would be 8. So now I'm really focused in on this right triangle here. And I can do 6 squared plus 8 squared equals the side squared. Or I could do the reduced triangle principle. And see that that's just twice a 3, 4, 5. So now I know the side is 2 times 5, which is 10. Now, if the side is 10, they ask me to find the perimeter. That's 4 congruent sides that share length 10, or 40 kilometers. On the next example, they're asking me to find the perimeter of a rectangle whose diagonal is 17 and whose base is 15. So when I draw out that rectangle and then label the values that I know, I'm hoping that you remember that that's a special in 8, 15, 17. Or you could do a squared plus 15 squared equals 17 squared. And then they asked me for the perimeter again. So the perimeter is the sum of all the sides. So 16 and 30 is 46. On the next example, they tell me that JG is an altitude to an isosceles triangle. We need to remember our axioms. If you have an isosceles triangle, then the altitude is the median. Even though we're not writing proofs anymore, all of these properties are going to come back and we'll need to apply them. So if FJ is 15 and FH is 24, if the altitude is also the median, then it's going to split that 24 in half, so this is 12. And we need to find the altitude. So we have A, 12, 15. I can factor a 3 out of that. And then I can see here that that would be 3 times 3, or 9. The equilateral triangle, I'm actually going to block this one out. You're going to have to do that on the homework, but I need a place to write. So the equilateral triangle, when we drop down the altitude, it's also the median. And it says the median is PM, or the altitude, and of triangle PKO. If PK is 4, well, if we have an equilateral triangle, that means it's also equiangular. And if we have 3 angles that equal 180, then one angle, and they're all congruent, one angle has to be 60. So that angle up there is going to be bisected. So now we have a 30, 60, 90, and the sides are in the ratio always of x, x root 3, and 2x. So the side across from the right angle is 4. Here's our equation. If 2x equals 4, then x equals 2. And then the value that we need is this altitude here, which is going to be 2 square root 3. In Moodle, you'd have to type that in as 2 asterisk SQRT parentheses 3. You could also do this using the Pythagorean theorem, 2 squared plus a squared equals 4 squared. And then you would have to simplify that square root. So knowing the specials and applying the reduced triangle principle can actually help you with already reduced radicals. There is one more type of problem that you'll see on this first day's homework. So let's say Bobby needs to walk from home to the pizza shop. So we're going to want to know what this distance is, but Bobby can't walk in a straight line. So he's got to go around blocks, around buildings. So let's say he has to go 2 blocks east, then 1 block north, then another 2 blocks east, and then 2 more blocks north. Rather than trying to figure out the hypotenuses of these individual triangles and adding them together, we can just make a single rectangle out of it. So instead, I'm going to look at it like this. And then I know the total east was 4. The total north was 3. And then this comes that special again. So the total, as the bird would have flown, would have been 5 blocks. Or you can always set that up. 3 squared plus 4 squared equals your distance squared.
If you found this video helpful, please like and subscribe. Smash that like button. You know you wanna. Come on, give it a thumbs up.